We can also look at equilibrium expressions, or write equilibrium expressions involving pressure. If we go back to the ideal gas law, which is PV equals nRT, P is pressure, V is volume, N is the number of moles, R is the ideal gas law constant, and T is the temperature in Kelvin. If we go back to this, we can generate the same types of equations that we just wrote for concentrations, but instead of using moles over liters, we can use units of pressure. So for this synthesis of ammonia, we can write an equilibrium with partial pressures. Remember, a partial pressure would be the parts that make up the whole. So we would do Kp, equilibrium constant expression in terms of pressure. The P just indicates that we're going to put pressure values in here. And then it's the same set of rules we used a moment ago. So we would have the pressure of NH3 raised to its mole coefficient, so 2. And then the partial pressure of nitrogen gas raised to the first, and the partial pressure of hydrogen gas raised to the third. So similar, except instead of square brackets, because we're using units of pressure or pressure values, we would do P instead of square brackets. So we'd expect to have atmospheres, millimeters of mercury, torr, kilopascals, pascals, pounds per square inch, those kinds of units. So there is a way to derive this equation. I'm not going to take the time to do that at this moment. But what you do need to know is that I will give you this formula. You need to know, because of the ideal gas law and the concentration, and using the pieces of the ideal gas law and getting us in moles over liters, because we could have that. We can manipulate the ideal gas law to get moles over liters, right? Because we can have moles here and liters here. We're able to derive a more complex, or a relationship, not that the relationship is complex, but a relationship between equilibrium of P and K. So this is Kp, so the K equilibrium of pressures equals K, so regular K, RT, all raised to the change in the mole value. Okay, and I'll explain all this as we go through here. So first thing I want to talk about is this is Kp and K. They're not the same thing, and it does matter where you plug K and Kp in, so be careful with that, being sure you see what kind of K value you're given or need. R is a constant. That constant, I believe, was back on this page right here, 0.08206 atmospheres times liters over moles Kelvin. So R is a constant. And because R has units of temperature in it, Kelvin, then our T, in order for it to cancel, has to be converted into Kelvin. Pretty much anything in chemistry needs to be converted into Kelvin, all Celsius or Fahrenheit converted into Kelvin before using. So back to the relationship here. So K and Kp, notice Kp's first equals K, parentheses RT, R is a constant, T has to be in Kelvin, raised to the change in mole totals. Okay, so how do I get the delta N, or the change in N? It is the sum of the coefficients of the gaseous products, so whatever is in front of here, so the sum of these two, so that if this was a balanced equation, the sum of C and D minus the sum of A and B. So I add up the products, so I add whatever is in front of my two products, or my product side, I add those mole coefficients, and then I add up the reactant side, and I subtract products minus reactants. Products minus reactants. All right, so before we get into using that formula, we're just going to practice good old solving for Kp. I'm solving for Kp. I'm asked to solve for Kp, and I have pressure, so then I just can straightforward plug it in. So as I look at this equation here, I'm given pressure values. I'm going to put products over the reactants. So the pressure of NoCl2 squared, because of the 2 in front, divided by the pressure of NO squared times the pressure of Cl2, and there's a 2 here and a 1 here because there's a 2 in front here and a 1 in front there, just like we did on the previous work. Plug in our values of pressure, okay? 1.2, that's what I had for here, atmospheres squared. Go through this and I get this value, and it's Kp because I plugged in pressure values.